subject is business statistics, first year, second semester. And what are the areas we are going to cover? For that, I may use this. Right. This is a snapshot. We may see in this chapter we will study something, right? That may new for you. Introduction first. Yeah. It has some branches. This is a mind map. You may understand very easily. This is not the entire journey of this subject. The subject, the chapter one, introductory chapter. It is about. It's giving introduction about some introduction about the basic knowledge about the statistics. Where we will study first the definition of statistics. Where we may find what is data collection, organization and analysis, interpretation and pattern identification, inference and prediction. In main branches of statistics, there are two. First one, descriptive statistics and inferential statistics. Under the descriptive statistics, we will talk about central tendency. It includes mean, median, mode, and dispersion variation. It may include range, variance, standard deviation, and data visualization using chart and histogram. And an inferential statistic, we may talk about estimation, hypothesis testing, and predictive analysis. It's come under inferential statistic. You may not familiar the terms till now, but end of the session today, you may get some basic idea regarding these two. And variable and type data types. Here you may study about quantitative and qualitative data, and we can further divide quantitative numerical data into discrete, countable, whole numbers, and continuous, measurable, fraction decimals. And in the categorical data, we may use nominal data, categories without order, and ordinal data, ordered categories. And the measurement scales, nominal scale, ordinal scale, interval scale, and ratio scale. And it may have a in-depth understanding on what is population, sample, probability sampling, and non-probability sampling. In probability sampling, we may study about simple random sample, stratified sample, cluster sample, and systematic sampling. And in the non-probability sampling, in my studies, study about convenience and purpose sampling, convenience sampling and purpose sample. And at last, the business application of statistics, decision making. We can use it for decision making, for market research, risk management, especially in finance students, quality control, production management, and forecasting in economics. So these are the things we have to discuss in this chapter. All things may covered entirely today, or part of it may covered today. Right. Now I move to the slides. Business statistics and introduction, harnessing data for strategic decision making. As I told you earlier, we will study here learning pathways. What are the learning objectives of this session? Fundamental concepts of statistics, understanding core definition and its major branches. We already discussed in the mind map. And techniques in descriptive statistics and inferential statistics. So these are the two main branches of statistics. and types and importance of variable types, and data types and measurement scales, sampling and sampling methods, and role of statistics in business. It's a business application of statistics. Before that, what is your understanding about statistics? What do you mean by stat? Stat. So it's your turn, my dear student. Uh, can you tell your views about statistics? Have you in your life, day-to-day life, do you face this kind of terminologies? It's your turn, please. So in the next 5 to 10 minutes, we will discuss about this concept statistics. Right. Uh, any volunteers? Any volunteers from you? Your side? Anybody else? What does it mean? Stat or statistic? Anyone? I want everyone you more interactive.
Yes, sir.
Yes, yeah. What is your understanding about statistics?
Statistics, it's a study of data.
Yes, very good. And right, this is study of data. Very good. And what else? So in simple term, you may every day you may talk about today I use mobile phone 2 hours and it consumed 5 GB of my data. It's statistics. My height is 5.5 feet. My weight 45 kilograms. Last night I studied 2 hours. Every day I eat 3 times. These are what? Also statistics. We are talking about the data, not mobile data actually. It's talking about the figures. How many subjects we are going to study today? How many hours you have spent for teaching, for chatting with your friends? All these are talking about some of the facts, right? Some of the fact. Today, it's a rainy day. It's a fact. So these are data, right? So here, statistics mean like it's a science, the science of stat. Stat mean, if you don't mind, you can keep, you can say this is stat means data. It's a data. So data, statistics mean data. So what is statistics? The science of data driven insight. When you talk about something, you highlight you try to strengthen your argument with some of the facts. Say for example, today I studied 2 hours. How did you measure these 2 hours? You're talking about the fact 2 hours, 120 minutes. Today my mobile has consumed 5 GB of data. This is a fact, right? So how do you get this information? Based on some of the sources. Say you from your mobile application, mobile app, you can measure. So stats like accounting and other things, statistics also is a science, the field. It has some systematic way, right? Systematic process. Statistics is a science that involves the step number one, collecting, right? Collecting data. After collecting data, you should organizing them. Organizing data in a proper manner, ascending order or descending order, analyzing them, analyzing the data, right, to find out to you're analyzing the data to find something which are hidden within the data and interpreting the data, right. Based on your analysis, you are going to say something, the conclusion about the data. So first collect, organize, analyze, and finally you interpret data. Interpret data. The purpose is to identify patterns. There are some patterns, right? You might say, right? You might say, morning, right? Morning. How many hours you have spent? How many minutes you have spent in social media? Morning, and in the afternoon, in the evening, the night, the date night. We may some of the trends. And if you have any social media pages, social media account, or what your YouTube account, you may see your trend, right? How many viewers, how many hours they viewed, or how many likes you have received, whether the number of likes are going upwards or going downwards, it's increasing or decreasing. It's a pattern, identifying pattern. Draw meaningful conclusion, from the after analyzing the data, you may find some of the conclusion, right? And solve problem. If you have any problems, you need some solution to provide solution for that problem. You need data. You make some of the investigations. Then you find the root causes of the problem, and to eliminate the root causes, you may suggest a solution. For that, you need the data, statistics. Right? This statistics is science that involves collecting, organizing, analyzing, and interpreting data to identify pattern, draw meaningful conclusion, and finally solve problem. It provides tools, statistics, right? Statistics provide tools for summarizing data, right? Summarizing data concisely for making inferences or prediction about large population based on sample. Here, the points, here the major point, the major new concept may introduced in this definition. Here, right, for making inferences, predictions, population, sample, major concept. Without knowing this major concept, it's very hard to understand the rest of the sessions in this subject. Right. You may have heard the term sample. What does it mean, the sample? Sample, any idea from you? Sample? Sample, what do you mean? What is your understanding? Sample. Sample is anyone? Okay, your time is gone. Right. Now we talk about descriptive statistics and inferential statistics. Descriptive statistics and inferential statistics, these are the major branch of statistics. Major branch of statistics. Right. Uh, right. Now, to have a clear idea about what is descriptive statistics and what is inferential statistics, we will use some example in our day-to-day life. Here you may find you are a person, you're an individual. You may feel sick sometimes. Then you approach a doctor. You may approach a doctor to get some idea, to get some medicines. Doctor suspicious, you may have a dengue, right? You may have dengue. Then doctor will advise you to take a blood test, blood test. Right. Now, please unmute your mic and let me know in your body in my body on average? What's the capacity? How much? What's the capacity of the blood in your body? How many liters in your body? Blood? How many? 5 to 6 liters, right? 5 to 6 liters of blood you have in your. So you may approach an MLT to test your blood. Normally, you may give him 5 liters, 5 milliliters of. So this 5 milliliter represents whole, right, whole blood, right, whole blood in your body. The MLT may test your blood, and he may prepare a report, right? In the report, he may state that the full blood count, right? He may test the full blood count. Yes. He says the amount number of WBC, red RBC, and your cholesterol level and your sugar level, right? He give say 10,000, 50,000, right? And 5 to 120. Like this report, is prepared by the MLT, right? And this report will be submitted to the doctor. Based on that report, doctor may come to the conclusion that what kind of disease you have in your body. From this example, can you tell me what is population, what is sample? What is population, what is sample? Here. What is population? What is population here? 5 liter or 5 milliliter? My dear student, please, be active in the class. Forthcoming lectures, purely calculations, so that if you behave in this manner, so it's very hard to understand. Yes, yeah, okay. Here, what is population? What is sample?
The average value of sample.
Sample is 5 milliliter. What is population? Population is 5
liter.
whole. Yes, whole blood in your body. This 5 milliliter, the sample. This sample represents your whole blood in your body. So now you can understand what is population, what is sample, right? This is the MLT report. This is MLT report. This report, based on this 5 ml or this population. He described, right? The MLT described in different manner, right? For example, you, right? You are an individual. When we ask you to describe about yourself, what do you say? Your name, your weight, your height, date of birth, NIC number, right? So this kind of things. So which are described about you. Describe about you. Likewise, MLT will describe about this 5 ml sample. And what are the description? This 5 ml having, right? The 5 ml has uh, the 10,000 WBC, 50,000 RBC, and sugar level is 120, this kind of thing. So this report is describe about this 5 ml, right? Then you submit this report to the doctor. Doctor may identify something, right? Doctor may identify something that it gives symptoms that you are under risk of dengue, right? Under this this conclusion he come, right? He take this conclusion based on this sample, right? Based on the sample, and finally he come to the conclusion that we have dengue, we have positive dengue positive. That he generalized this 5 ml, report will infer, right? Infer for whole population, right? So this is called what? Inferring, generalize. He generalize. Generalize means is 5 ml, right? He take the 5 ml from a whole of your blood, and this 5 ml fully represent your 5 ml blood, 5 liters, 5 to 6 liters blood, and then it has some of the abnormal things in your blood. So that based on that report, he says the doctor come to the conclusion that we have dengue positive. Dengue positive. This is called inferential. Yeah, inferential, right? Inferential. So now you can understand here. Now you can understand what is population, what is sample, and inferences. We will talk about prediction. Prediction mean the last month in your social media post you get 1K likes last month, and this month you may get 5K likes for your content. The next month you may probably get 10K likes for your post, right? So this is what, based on the past data, he predict, right? We do predict. That is called what? Prediction. Based on the past facts, we do some of the prediction. Now, well, let us dive. So, what is descriptive statistics? Descriptive statistics is to summarize the purpose of the descriptive statistics. You know, the MLT report. Recall the MLT report on the 5 ml blood sample. What the purpose of the testing? Summarize and organize data in a meaningful way. Descriptive statistics. In the descriptive statistics, you may see the average number of students in the class, average number of students, or the average marks for subject, the rank, or the maximum marks, minimum marks, and how many likes on average per day, how many watching hours per day, how many hours spent on the social media per day, per week, per month, how many hours you do sleep, how many hours maximum, minimum, how many right how much you are spending every day on average. So this is what summarizing. It, it represents about you, right? About a particular sample. The purpose is to summarize and organize data in a meaningful way. It answers what has happened. What has happened? It's described, right? It's a describe. And the key tool we use graph, table. I graph in this kind of charts, tables. You may find that the frequency table, right? This kind of table like this, and measure of central tendency. Measure of tendency. Here we thought about average, maximum, minimum, mean, median, mod, right? These kind of things. It's measure of center tendency, and dispersions are maximum, minimum, and the range, right? And the standard deviation, variance. This comes under dispersion. We will discuss in depth in forthcoming classes about this. Second branch, statistic, inferential statistic, as I told you earlier, based on the sample, right? Based on the sample, 5 ml blood, the doctor come to the conclusion that the particular individual has positive dengue. What the purpose of inferential statistics? Inferential means sample to population. Sample to population, right? Inference, generalize. You pick some of the students. You pick some of the students, and you may observe some of the behavior in particular group that student may represent, or the friend, your individual may represent that particular a particular ethnic group or particular village or particular town or particular community. You observe that person, that individual, and after that you generalize all students, all individuals from that town look like this, they behave like this. So this is the practice of this community. How do you go to know? You observe only one or two of individual and you generalize. Sri Lankans, like this. For example, you may observe the Africans. Their skin color is black, curly hair, right? And they have a different, right, so different aesthetics, different face cuts, and different language. Then you only have seen very few people of from Africa. They represent Africa. Then you think that you say that all Africans are black and all Africans are having curly hair, right? So the purpose of inferential statistics is to make generalization. This is very important. Make generalization or prediction, forecasting about population based on sample. You see, this is the point. Make generalization or prediction about population based on the sample. It answers the question. For what question? For what could happen? What in the future? What could happen? This is what prediction. Or what does this sample tell about the whole? You know, the doctor has taken only 5 milliliter of blood sample and he come to the conclusion about your body, whole blood in your body. This is generalized. And the key tools, hypothesis testing, key tools, hypothesis testing, right? Hypothesis testing, it's got repeated, right? And regression analysis, confidence interval, so that there are a lot of techniques you might study in this course unit. So those are coming under inferential statistics. Right. Up to this point, do you have anything to clarify? Any doubt? If you have no doubt, uh, you can use emojis in your WhatsApp. So not WhatsApp in the Zoom. Right? You can write them. So there are options for that, or else you can ask any questions. Okay. Anything? Anything else? Is it clear?
Yes, sir.
Then we will do small. Right. We will do deep dive on descriptive statistics. Right. painting a clear picture of your data. Descriptive statistics simply it not defines, it tells you painting a clear picture of your data. So now you are going to describe about your data. Key summarization techniques. In statistics, we have some techniques to summarize or to describe the data. First one, the measure of central tendency. Measure of tendency. Its typical value in the data sets. We may find about mean. Mean, arithmetic mean. Sometimes we call harmonic mean, geometric mean. There are a lot of different types of mean. In our day-to-day life, we call them as average. Average, right? Mean is an average. Median is a midpoint, point in the center. The mode, how many times a particular value occur several times, most times, right? Mode, mean, median, mode, M. So these are measure of central tendency. And measure of dispersion. How does your data varies, right? Variable in your data. Say measure of dispersion is the spread or variability of data. Range, variance, standard deviation, that is so, right? Um, uh, for example, right? For example, um, when you post a video in your YouTube or when you post a post in social media, right? So this is a timeline. Post one, this is post one, post one. This is post two, and post three, post four, post five. Right? There are 4, 5. In your first post, you received 2K likes. The second post, you may receive 3K. In third post, 1K. And the fourth post, 5K. In the fifth post, 4K. Right? Likes. Can you tell me, on average, how many likes you receive? On average, how do you find on average mean likes? Anyone? On average, how many likes for your post?
3K.
How did you find? How did you find that?
Adding all the likes and dividing by 2.
Very good, very good. 2 plus 3, 5, 6, 10, and 15. All for 5 posts, you got 15,000 K likes, 15,000. And how many posts? 1, 2, 3, 4, 5 posts. On average, you receive 3Ks. 3. So it means you can say if I post a post in social media, Instagram or Facebook, I receive 3K on average. On average, I will get 3K. This is central tendency. And what is the maximum likes you may receive? Maximum likes for your post?
5K.
5K. Very good. 5K. And minimum?
1K.
1K. So this, yes. So here, this term average talk about the central on average, but here when I talk about what's the maximum, what's the minimum, so these are talking about variability, varies. So you can say that when you do a post, when you make a post in your social media, it ranges from 1K to 5K. It's a range 5K to 1K to 5 range, then you are in the middle, right? So most of the time, the post is like this. There are a lot of chances that you may get 3 likes. Sometimes it goes like this. In between, you can get likes in between this. Minimum 1K, maximum 5K. This is called range. It's called range. Maximum minus minimum. That is range. So this is person 1, right? Person 1. We talk about a person 2. Person 2, right? 1, 2, first post, second post, third post, fourth post, and fifth post. In the first post, he get like say 5K. Second post 0.2, and third 0.2K, and in the third 10K, and fourth 7K, and fifth only 2K. 2. Right here. So average. What is the average? Yeah. What do you do average? How do you calculate average? 5, 10, 7 plus 2 plus 0.2. Then divided by 5. Can you calculate very quickly? Or I will make it 0.8. This is 0.8. 0.8. For your calculation easy. 5 plus 10, 15, 15 plus 7, 22, and 23. Right? 23, we will make it 8, right? So now easy for calculation. How much? 24 over 5. Again, calculation hard, no? So we make it 6K. Then 25, right? 6K, 10K, 8K, 0.8K. Then on average, he gets 5,000K, right? 5,000K. 5,000K. In the middle, 5K, and here minimum and maximum. What is minimum here? Minimum
0.2.
0.2. Very good. 0.2. Maximum
10K.
10K. 10K. The variance.
10K.
And here, yes, in the person 1, right, when we look at the person 1, on average, he got 3K, maximum 5, minimum 1. Right. So this is his range is 4. His range is 9.8. The range is 9.8. From this is person A, this is person B. From these two individuals, among these two individuals, right? Which social media influencer has more reliable, A or B? More reliable mean we can trust. Whenever for promotion or advertisement, we approach A or B. Who is more reliable?
B.
B. Right. Any other answers? This is general. It is not statistics. It's general knowledge. Without knowing this statistic in your back end of your brain, it's work. Statistics work. So based on this observation, can you tell me A or B is reliable? Who is reliable, more reliable, who is less reliable influencer? I want to give advertisements to make promotion. I want to choose A or B. A or B. Who is more reliable? Right. If you are unable to understand, right. I give one more example. You ask, you invite a friend to attend for a particular meeting or to visit some event. So one, your friend A, he promised to come at AM. Right? Both, right? Both A and B agreed to come, A and B, right? So you observe 5 meetings. Observe 5 meetings. A, right? A sometimes comes 9:30, sometimes comes 10:50, or sometimes the next meeting 8:30 and 12 and 11:30. This is behavior of A, right? To attend the meeting at 10 a.m. And B, right? Person B, he attends 9:45, 10:05, 10:05, or 10:15, 9:50, 9:55. Who is reliable on his promise? A, this is B, this is B, this is A. Who is reliable on time? No, attending time.
B.
B.
B, sir.
B. Why is that? Why? Why you say maximum? What is the maximum time?
10:50.
Maximum delay? 10:50.
10:50.
Yes, 10:50. 10:50. Early? Too early?
9:45.
9:45.
9:45. 9:45. So what is the range here? Range? Maximum minus minimum? Range?
30 minutes. Half an hour.
Yes. Yes, half an hour. Only
30
30
minutes.
minutes. Only 30 minutes. When we look at Mr. D, what's the range? Sometimes he come too early, 8:30. Sometimes he come, well, too late. How many hours? 3:30. Right? The range. The range. Then can you tell me who is more reliable? A or B?
B.
B. Why do you say that conclusion? Why did you say? Why? Why? Because his variation,
Because
the time
he doesn't.
variation is less. Time variation is less for Mr. A. Time variation for Mr. B is too long, right? So variation more range. So more variation, more reliable. So less reliable. More variation is less reliable, and less variation, more reliable, right? So based on the same principle, can you say here social media post who is more reliable, A or B? A or B?
A. A, sir.
A. Why is that? He has less variability. He has less variability. When you give a promotion, a task to Mr. A, you can promise, right? He can promise, we can expect at least the minimum you can get 1K minimum, maximum 5K, and it's not much risk. And when you look at B, even though we go to the peak, sometimes you may end up with very less outcome influence in the social media. So which is benefit to you giving advertisement to Mr. A or B?
A.
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 A because yeah, A is less variability, therefore he has more reliability, right? Okay. Now we just look at this slide. Look at this slide. Now we can understand. Any questions about descriptive statistics? So you know what is average and what is range, and variance and standard deviations are little advanced. We need advanced, little, not actually advanced. You need some more calculations. The range is a difference between maximum and minimum. That is the basic measure of variance. The mean is the basic measure of center tendency. Right, the variance and standard deviation we will discuss in detail in forthcoming classes. Right. The tools, right? We may use bar chart, pie chart, histogram. Right? We will learn in forthcoming classes. We will learn how do we create this kind of bar chart, pie chart, histogram manually, right? Manually, plus using Excel as well, Microsoft Excel as well. Right. Let's see the scenario. Right. Scenario: monthly sales revenue of a company's 5 regional offices. The values are given in thousand. There are 5 offices, A, B, C, D, E, and the sales revenue in $1,000. You can see that descriptive study calculation the mean revenue, right? Total of these and divided by number of observation 50, and the sales range maximum range 60 and minimum range 20 and 40. Then the range is 20. So this is simply descriptive statistics. Now we come to the point of inferential statistics. Infer, generalize, right? By observing few cases from a particular population, then that observation may be generalized to population. So that's why I tell you some sample insights to population prediction in your blood report. In your blood report, the blood report say something saying it describing about the 5 ml report may represent all of your 5 to 6 liters of your blood in your body. Infer, doctor, infer this. So core methodologies, what are the things may be used in inferential statistics? Estimation. Using sample data, determine the population parameter. In your class, if I do some data collection in your class, say the weight, right? Weight of each student or height of each student, right? Then, right? Can you post? Can you just for fun, right? Can you post your height in your class, right? Everybody, I want to see who is in it, who are active in the class, right? Can you post your height in centimeter? Right, quickly type in the chat box. Right, 168 centimeter. 68, 60, 72, 53, 79, 79, 60, 186, 71. Please don't know. Okay, interesting. 57. 153, 45, 58. Okay. 177. 16 cases. 68, 84, 84. Very tall. 57, 70. 153. Right. By looking at these numbers, we can come to the conclusion on average 150 or 155, right? So based on that, so I take you, the students in my class, this subject, the sample. You are first year students. First year students. I do collect data from you, and right, then based on this, I if I say, right, if I do calculation like uh, if I enter your data in Excel sheet under 67, 68, 84, 59, right, say altogether 88 students in the class. If I describe average weight, average height of the students 180, 160, maximum 186, minimum 145, and the median, and mode, variance, standard deviation, like that. So if I do, and based on the data, I can draw graphs, bar chart, a pie chart, like that. So that describe about the class only. Right? It describe the students in the class. Based on that information, based on this data, right, I can generalize all students in the university system who are in the first year, the average height would be 150, right? 150, or like that, or 160. So whatever the value I receive. So that is descriptive statistics. Descriptive statistics mean describing about only the sample, 88 students. Based on that, say I come to the conclusion that the average, on average, the first year students in the state universities in Sri Lanka, on average 160. This is what I generalize. I generalize this sample finding to the whole population, the estimation. So what I did actually, using the sample data, I use a sample data, sample U, right? Your class is a sample, my sample, using the sample data to determine the population parameter. The parameter here is your height parameter. And hypothesis testing, right? Formally testing assumptions such as whether two variables are related, right? I can test. I want to do a research that the time spending, right? Time spending in social media, say LinkedIn or YouTube, right? Right. We will talk about the YouTube, not social media. YouTube. The amount of time and time spent in YouTube and GPA, academic performance. There's a positive relationship between the amount of time spent on YouTube and academic performance. How do I argue that? And I argue, uh, my argument is the amount of time you spend in YouTube may lead to higher academic performance. So this is my assumption. Then how do I test this? Any idea from you? How can I prove it? How can I prove? Anyone? I want to get some basic idea from you. Just please. What I can do? I want to prove YouTube engagement will enhance academic performance. How do I do it? How do I prove it? How do I prove this? Any idea? I have to collect data from you, every one of you. How many hours you spend time on YouTube? Morning, how many hours? Evening, how many hours? Daytime or night time? Then I ask another second question: what is your GPA? What's your result in your last semester? Then I collect data from a particular group of students. It should generalize, right? It should represent many universities, many batches, different batches within the university system. Then I do collect the data and I test. Are there any relationship between these two based on the sample? Then it gives it may give conclusion, and the data analysis may give me a conclusion that it is positive or negative, whether my assumption is correct or not. Then if I found there is a positive relationship between the time spent on YouTube and the GPA, then if I found positive in the sample, I can say that the students in Sri Lanka in the university system who spend time on YouTube may lead academic performance. It's my generalization. It's my generalization. Right? This is hypothesis testing. Hypothesis means assumption testing. Actually, technically, assumptions and hypotheses are not same. Technically, there are differences. You may get the differences clearly in the future sessions. Right. And yeah, next, the predictive analysis. Predict. You may study that. You may heard about the machine learning. May predict in the forthcoming election who will win the election, who will be the president, who will be the chief minister, and what is the rainfall tomorrow, the next week, next month rainfall, and right, many, right. You can do prediction, making future prediction, based on current trend and relationship. In the school examination, public competitive examination, you can predict. So these particular students may go through the exam and pass, right? They may what the reward he or she or he may got the first place. How you got to know that? How you able to predict? Most of the times, your prediction is correct. Why? Because you do prediction based on the past data. The past data is a sample. The available data in your hand is your sample. Based on your sample observation, you can predict the future. What will happen in the future? So that is predictive analysis. What are the real applications, business applications of this inferential statistics? The business financial analysis here assessing investment risk and modeling financial performance, which means you may want to invest in stocks in the Columbus Exchange stocks. Some stocks will give you return, high return. Some of the risk may give you loss. Then how do you find it? Which company stocks will give you more profit, more return? Which company's profit risky? So those kind of things you have to analyze. You have to choose the stocks which are giving you high return, and you have to avoid the stocks which will give you loss or make you loss. For that, you need this kind of analysis. You have to choose the stocks based on the past behavior. And market research. If you are work in a marketing department, marketing companies, a marketing manager, you want to guess what our customer actually likes, what kind of design they do like, what kind of features do they like. You want to study. You need to study about your consumer, right? Then only you able to satisfy your customer. Then only you can attract customer and boost your sales. Sales forecasting. Sales forecasting. Right? If you are working in production department, manufacturing companies, you have to produce sufficient products to ensuring product product availability in the market, no shortages. Forecasting, sales forecasting, how many units you are going to selling in the future. So predicting future revenue stream to guide the planning. What the plan you need to ensure availability of your stocks, your product in the stock. You need to produce sufficient product, so that you need to purchase sufficient raw material. You need to hire sufficient number of employees. You need to um, make some other arrangements, right? Transportation, insurance, renting, right? Everything we have to do based on the sales forecast. Quality control, using sample of product to ensure quality across entire production run. In the production process, you have to randomly, for example, the milk powder, it produces 400 a packet. Standard packet is 400. Then if any packets less than 400 or more than 400, will make you serious consequences. So therefore, make you have to make uh, assessments in yogurt production or milk production and other food production. If your food make any adverse impact on your consumer, right? Say food food poison or something like that, you have to ensure that your product are safe to use. Then it is impossible to check each and every product. You can't test each and every product. You can't measure the weight of the milk powder packet. You can't. It is very hard. Or you can't test all yogurt, all products, all foods, right? You can't test. So what do? You have to choose some of the items randomly, and you test whether is whether is appropriate or not, whether it's exactly 400. So it may range. You can see, observe, it may plus or minus 5 grams, plus or minus. It means 395 to 405. That it varies within that. And economic planning, in our country are facing economic crisis, and early in 2023, mid of 2022 and 23, we had a serious economic crisis. For that, government has to take uh, steps to stabilize the economy, and they have to plan. They have to plan plan the stabilized economy. For that, they need past data and economic forecasting and prediction. So this is about descriptive statistics and inferential statistics. So these are two main branches of statistics. Here, then building blocks of data. Building blocks of data, understanding variables. Variables mean the varies for time. Variable. For example, I ask you to put your height. It's a variable. Height, it's a variable. It varies in each and every observation. Everybody of you having different value. It varies, right? It varies. It takes different values at different times, right? Or times different cases, or time different cases. So that is variable. Your age is a variable, your name is a variable, your height is a variable, your religion is a variable, your district, right? Your phone model is a variable. Those are variable. So building blocks of data, understanding the variables. What does it mean? Variable. In statistics, a variable, right? A variable is any characteristics that can take different values, right? It will take a different values across individuals or units. When I when I ask your height, everybody you place a different values. It varies. But character, what's the character? The height, the character. It differs across individuals. So therefore, that is variable. Variable represent data. Variable represent data that is collected. I collect your height and collected, measured, and classified. Right? I can classify tall and short, and I can classify you in gender. Some of you are male, some of you are female, right? Classified in a study and play a crucial role in organizing and understanding data. Variable, right? The variable is not avoidable. In statistics, not only statistics, in any field, the term variable cannot be avoided. In the next 4 years in your degree program, many times you will hear this term variable. In my study, right, I'm going to collect data, right? I'm going to do a research. For that, I'm going to issue some questionnaires. I'm going to issue some form to you, and you have to respond on that form. For each individual has to fill that form. In that form, you may see, right, the age, your age. So quantitative or qualitative. Your age in number. Your age is your number. Your height in centimeter or in feet is quantitative. These two are quantitative. Gender, right? Male or female is qualitative. Does it has number? Does gender has number? No, it's a qualitative. It's a qualitative data. So data can be classified into quantitative variable. So variables, not data actually. The variables can be divided into quantitative variable and qualitative variables. Some data in the form of quality. a major field of study. Say, for example, what is the major field of your study? You may say in your group, if I issue this question now, you may say, I am management. Major field of your study is management. When we go to the arts faculty, they may say arts. Engineering faculty, they may say engineering. In science, they say science. Humanities, social science, medicine, and field of study. It has no value, no number, no measurement. So these are qualitative variables. So variables we can divide into two: quantitative variables and qualitative variables. The primary classification of variables can be quantitative and qualitative variables. The nature of quantitative variables is numerical values. When I talk about your age in number, right? Number, your height, number, your weight, your number, how many hours you spend, number, how many students in your class, number. So those are quantitative variables, numerical values representing counts or measurements. Example, age. What's your age? How much revenue? Today's revenue, annual revenue, monthly revenue, the temperature, the heat, the temperature of the classroom, temperature of the surrounding, on average temperature of the country, of the district, number of items sold. All of these items represent numbers. And qualitative variable, qualitative variable. When you look at the nature, these are categorical variables. Category. Male or female, right? Category. What's the major field of study? I'm commerce, I'm management, I'm arts, I'm engineering, I'm medicine. Which fruit you do like? Which fruits you do like most? I like banana. I like mango. Like that. What color do you like? Green, red, yellow, blue. It has no order, right? It's a category representing labels or attributes. What is your skin color? What's your skin color? What color you do like? And which field do you like? Marketing, accounting, HR, or what kind of profession you do like? Academic, industrial, marketing, right? Sales, finance. Right. So example: gender, product brand, Apple, Samsung, Micromax, Nokia, right? NVO, right? Country: India, Sri Lanka, Maldives, Nepal, Australia. Major field. These are the what? These are the categorical. It has no numerical value. So that is qualitative variable. Right? We can divide the variables, right? The variables further, right? We can divide the quantitative variables, the number, the numerical variables further, right? Not qualitative. We can divide the variables into two: quantitative variables and qualitative variables. Again, we can classify the quantitative variables into two, as discrete variable and continuous variable. Discrete variables and continuous variable. Discrete, it has a full number. It has full number. Discrete value, that discrete variable, a variable with countable, right? It's countable numbers. How many students in your batch? How many students? How many students presently attend in the class presently? How many students? How many students in the class? How many departments? How many faculties? How many academic staffs? How many classrooms? How many phones you have? When you answer for this kind of question, you say in full numbers. A variable with a countable, distinct value. These variables are whole numbers, right? This is very important. These numbers are whole numbers representing count and cannot be take of fractional values. So for example, when I ask how many students in the class, you may say 88, 85. You never say 8.5 students. How many faculties? 3.5 faculties. How many universities in Sri Lanka? 17.25. You can't say, right? These are whole numbers. It's called discrete variable. It's called discrete variable. So values are clear, distinct, and countable. How many mobile phones you have? How many SIMs you have? Right? So these are what? These are discrete variable. For example, number of employees in the department. Number of employees in a department. Some might say 25 employees, 30 employees, 50, 100,000 employees, like that. Not 20.5, not 30.2225. No, we cannot say. Number of items sold in a store. How many items you sold? 10 items, 15 items, right? Number of customer complaints per day. 5 complaints, 12 complaints, 20, 50 complaints per day. You cannot say 5.12 complaints, 7.53 complaints, 10.06 complaints. You cannot say. You have to say concretely in whole numbers. A countable number is a discrete variable. It's a discrete variable. And continuous variable, in other side, it may have, right, it may have frictions, the decimals value, the full number including decimal. For example, what is your height? People say 5.5. 5.5. How many hours you sleep? 6.25 or 5.5 hours, 8 hours, 8.5 hours. Right? It includes both full countable number plus full number plus decimals and fractions. Fractions mean it is 1 over 5. This is fraction 1 over 4, 5 over 2 over 5. It's a fractions 0.25. Decimals, right? Decimals and 0.33. Decimals 0.967. Decimal values. The variable that can take any value, within a specific range, including fractions and decimals. These variables represent measurements, right? These variables represent measurements, right? The height, weight, right? Values are not limited to whole numbers. Values are not limited to whole numbers like discrete. Infinitive infinitive possibilities within the number. Say for example, when I ask you how many numbers 5 to 9, how many numbers should be in 5 to 9? How many full numbers? How many full numbers? 5, 6, 7, 8, 9. There are 5 numbers, 5 full numbers. How many decimals between these 5 to 9? How many decimals it has? How many fractional numbers? Yeah. 5.1, 5.2, 5.3, 9.9, 9.9, 9.9999998, 9.9999 and 0.0125. Right? So there are a lot of numbers, infinitive possibilities. infinite possibilities within the range, right? So this comes under continuous variable. Examples: time taken to complete a task, a particular task, to 1.2 or 1.25 hours, 5 hours, 6 hours, 2 hours, 2.5 hours, 7 hours, 7.5 hours, like that. And weight of the product, weight of the product, 12 kilograms, 5.2 kilograms, 5.5 kilograms, 15 kilograms, 25 kilograms, 25.5 kilograms, room temperature, 22.4, 23, 27, 28, 28.9, 28.9997, and that's all. So these are what it may take the fractional number plus decimal numbers, including full number. Right. Aspects. Right. Now let us differentiate these two. The nature of values in terms of discrete value and continuous value. The discrete values are countable, limited to whole number. As far as we concern, in the continuous variable, these are measurable, right? It can take any values in the range, say 1.25, 1.5, 1.75, and it takes any value within the range. Number of books, family size, employee count, so these are in full number. And the countable variable here, weight, 1.5 kilograms, 2.5 kilograms, 2.225 kilograms, distance, kilometers, time, seconds, milliseconds, nanoseconds, and temperature, right? Celsius, Fahrenheit, Kelvin, right? You can measure. Right. So, type of data, we will study this one in the coming lectures. Next lecture, yeah, tomorrow, we will discuss type of data. So up to this, do you have anything to ask? Any doubt?